When I last spoke to you, we were working with binomials that were getting too difficult to solve, like this example here. Binomial n is 20, p is 0.6, and we wanted to figure out the probability x is less than or equal to 7. Challenging problem to solve using the binomial formula. And so we talked about using something called cumulative binomial tables. Now the tables give less than or equal to probabilities, and that's going to be your challenge initially when trying to work with the probabilities. I get asked all the time, do I use these tables? And the answer is no, I don't. And then students give me that frown and say, well, why do we have to? And the answer is, well, the type of information I get from the computer is comparable to the type of information you get from these tables. You're going to get less than or equal to probabilities. Actually, the probability I like that the computer gives me is a less than or equal to probability. And so I want you to learn how to work with those. And we're going to use the tables in class and in the videos here and on exams. If you change to using the computer in the future, it's not a big deal. It's still a less than or equal to type of probability you're going to be getting. So how do they work? Well, I'm going to suggest we do something called the Dummeldinger dot diagram. And you might be thinking, what the heck is that? Well, let's look at an example. Let's say we have a binomial, and I'll identify n and p. N is 15, p is 0.4. And now what I'm going to do here is I'm drawing, you can draw just dots. Typically I just draw dots, but I drew circles. And I drew 16 circles. Why 16? Because if I have a binomial with an n of 15, the values of x, there's 16 different values of x. There's 0, 1, 2, 3, all the way up through 15. What these dots are going to represent, what you want you to think about, are these the different values of x. Like right here, that's the one I'm putting the x in right now. That's the value of x equal 4. Here's the value of x equal 11. And what I want to show you is that these dots can help you figure out probabilities. What do I mean? Well, here's an example. Probability x is less than or equal to 8. If you're going to use the formula, you're going to have to go to the value 0, at 1, at 2, at 3, all the way up through 8, and add them together. And really what I want you to do with the dots is draw a box, a rectangle, around the values of x that we want to include, less than or equal to. That equal sign is there. And so I'm going to draw a box around those 9 different values of x. And the beauty of this is that's the kind of probability that's less than or equal to probability right here. It's the type of probability that my tables will give me. So we need to go to the n equal 15 table and look at the p equal 0.4 column to find the value of k equal 8. What does that mean? Well, let me show you the table. Here is one page of the tables in the back of the text. And you can see that the tables are sorted first by the value of n. And so if we have an n equal 15, we're going to be using this table up here. And then we go find our value of p. And in this problem, I'm saying let's use 0.4. Now, a lot of times I try to use smaller tables. It's just easier. And so what you can see over here is, I'll show you in a second, how do we find 8? We come down here to the value of 8. And we come over and we get this probability, and we see the 0.905. I'm going to use a smaller table because it's a little bit easier. I've just taken these 3 columns, whoops, and made them a little bit bigger. Okay, one important thing to know, this is the n equal 15 table. Notice there's no n equal 15 row here. I'll talk about that in a second. This is the n equal 20 table. There's no n equal 20, and you're going to find this in all the tables you see in the text. That last row isn't there. It doesn't really matter in this problem, but it will in the next one. Probability x is less than or equal to 8. Find the value of 8. Find the value you want less than or equal to 4, and then come over to the right column. Here's the p equal 0.4 column. This isn't the probability at 8. It's the probability x is less than or equal to 8. And in this case, that's our answer. You'll notice it's the same that we see right here. It's just a little bit easier, a little bit bigger if I use this smaller version of the table over here. That's how they work. And you might be thinking, that's pretty easy. You asked me to look up the value at 8. I look up the value at 8. There it is. So what happens when I ask you to do something different, like the probability x is greater than or equal to 4? A lot of people are saying, well, there's 4. And I'm going to say, yeah, but there's a wrong answer. So let's think about it. Here are your dots. Okay, I got a different dot for each of the values of x. Which values of x are greater than or equal to 4? Well, obviously the ones out here are greater than or equal to 4. 6 and 5. Is 4 included in this? Yeah, it will be. In fact, 4 through 15 is what we want. Now, if I look up the value of 4, that's not the probability x is greater than or equal to 4. That's the probability x is less than or equal to 4. And so we have to get tricky now, get clever. And I usually refer to this, you got to play the binomial game. I'm going to ask you a probability, and you're going to have to figure out how to solve it in terms of less than or equal to. Here's what I know. I know the probability x is less than or equal to 15. I know the probability in here. And you wait a second, it's not on the table. And the reason it's not on the table is because you already know this. We know that the probabilities all have to be between 0 and 1. Now think back, what do we say? If we sum up all the probabilities, what do they have to be? 1. The probability x is less than or equal to 15 is 1. So this bigger rectangle here has a probability of 1. You say, great, what does that help me? Well, I don't want the whole rectangle. I want 4 through 15. I want these guys right here. These are the ones I want. I don't want the ones out here. And so I'm going to rethink it. It's the probability x is less than or equal to 15. I'm just going to write that as 1 minus the part here I don't want. So why am I thinking of it that way? Because I'm rethinking it in terms of less than or equal to. Because right here in the table, I can find the probability x is less than or equal to 3. The probability over here is 0.091. What's the probability over here have to be? The difference between them. If I ask you for the probability x is less than or equal to, or greater than or equal to 7, I would draw a line here. I would include greater than or equal to 7 on this side. It'd be 1 minus the probability x is less than or equal to 6. It would be 1 minus that guy. You got to get clever. If I don't have that equal sign there, if it's just greater than 4, well, then this line would shoot over to here. So you got to get clever. There's a couple different variations that I can ask you. Look at this one. We saw a problem like this earlier where we asked the probability exactly half, I think is the way I asked it in a problem. Well, what's the probability? X is equal to 10. And the probability was 20 ohms, so it was probability x is equal to 10 is what we solved. What is the probability x equal to 10 in this problem? Well, there are your dots again. Now, it's really easy for me in this video to do the dots because I'm the master of copy and paste. Do you have to draw out all the dots? Well, hold that thought. I'll talk about that a little bit more in the next problem. The answer in most cases is no, you don't. Which values here, which values of x do I want included with x equal 10? I just want this guy right here. This would be one where you could run through the formula because you only have to run through it one time. Now, I say that. Would I run through the formula? Heck no. No, I'm going to avoid the formula at all costs. I'm going to go to my table. I'm going to get this value right there. And some of you are going to get that value right there, and you're going to go on a multiple choice exam, and you're going to see that number. You're going to be like, score! Is that the answer? No, it's not. Why? Because that's the probability not equal to, but less than or equal to. That's this right here. 0 through 10. I don't want 0 through 10. I want 0 through 9 to go away. Well, how do I make 0 through 9 go away? I subtract it. And so I get clever. I take the probability x is less than or equal to 10, which I can get very easily from my table. Think about that now. That's a difficult probability. Think of all the work that went into this probability, using the binomial formula, summing it together. That's a lot of work. It's real simple in the table, though, isn't it? That's the probability. 0.991 is the probability x is less than or equal to 10. 0.966 is the probability x is less than or equal to 9. What's the difference? Well, the difference must be the one we want, the value at 10. It's a very straightforward way of solving binomial probabilities. All right, so let's take a look at a couple examples. In fact, let's go back and take a look at the examples we've done already. Suppose it's believed 60%, there's our P, have at least one operable smoke detector. The town's fire marshal randomly samples 20, there's our N, so there's N and P, to determine the status. We have a binomial with N equal 20, P equal 0.6. Find the probability exactly half. Well, that's the probability x is equal to 10. Now, do you need to write out all the dots? You can see I didn't. Here's what I will tell you. In general, when you're doing dots, put in the value 0 always. Put in the value of n always. And then the only other dots you need are the dots that I'm interested in. In this case, it's a value 10 and 1 on either side. Because really what you got to do, think about what we did in this last picture. Look at this picture. It's a mess, right? But what did we do? We drew boxes. And the key to solving binomial probabilities is knowing which values of x you want to include. The key to solving binomials is knowing which values of x you want to include. I want to include just 10. That's all I want in this problem. And so again, this is a great problem because when I look up 10, Great problem to solve using the binomial table. When I look up 10, it's going to give me less than or equal to, just like that last problem. Every time you look up 10 in the table, it's going to give you less than or equal to 10. Every time you look up 7 in the table, it's going to give you less than or equal to 7. So try to figure out how to use the less than or equal to's to give you the probabilities you want. That's not the probability I want. When I go to my table, looking up the probability at 10 is not going to give me the probability I want until I get rid of the probability at 9. So I pull my table in, I go to the table, and I look up the probability, except now I'm looking at 0.6. I look up the probability at 10, that 0.245. I subtract the 0.128, and I get to 0.117. Now, if you look back a couple pages in your notes, look back to when we did this problem using the formula. We got 0.11. Let me look back. What did we get? 0.11714 using the formula. And I'm going to bet you just watched me do it. You didn't actually plug the numbers in yourself. You can use it. You can use the formula if you like. I'll always give you a table to solve these probabilities. If you want to attempt the binomials just using the tables, I'm completely fine with that because I promise you will always have one available to you. The problem that I stopped at after I did the discussion of the binomial was this one. Find the probability that more than 7 of the homes have at least one operable smoke detector. And we looked at that and said, that's too difficult. Well, look at the dots. Again, put in 0, put in M. What's more than 7? Well, these guys are more than 7. And this is where you got to be careful, because in another version of this question, I might ask what's the probability at least 7. And so I would include the 7. I'd put the equal sign in here, but I don't. More than 7 is 8 through 20. That's what we want. Okay, anytime you see a greater than, every time you see a greater than or equal to, you're going to have to turn around. We know that what I'm putting in this rectangle right now, that's the value 1 minus the probability x is less than or equal to 7. Typically what I say is when you draw these boxes, take a look at your box. Go to the right-hand corner of your box. Look that up in the table. What's the probability x is less than or equal to 20? That's where you say, well, there is no, that's because it's 1. That's where this number comes from. So start in the upper right-hand corner or the right-hand side of your box, not upper, the right-hand side of your box, and then subtract 1 right just outside it on the left. So look up the value at 20. Again, you can. It's 1. Minus, look up the value at 7. You can look up that one. Look up the value at 7, and you see the 0.021 over here. We just finished this problem, and we said it's too hard to solve using the binomial formula. Yet it's a very simple problem to solve using the binomial. Once you identify a binomial, you can solve extremely complicated probabilities very easily as long as you identify it correctly, as long as you get clever and work through the less than or equal to's. Again, I've said this before, I'll say it again. If you're going to say, well, it looks good when you do it, Mark, I think I'll take my chances and have the first binomial be the one I do on an exam, you're in for a fall. It looks good when I do it. I hope it looks good when I do it. I'm pretty good at this stuff. Should be after 30 years, for crying out loud. And so I need you to practice. And actually, I don't need you to practice. You need you to practice. Your grade needs you to practice. Don't believe me? Don't practice. See what happens. Please don't take that dare. All right, so that's how we use the binomial tables. Okay? Pretty straightforward. Let me show you one other example. Mars Incorporated, the makers of M&Ms, I love M&Ms, claims that 40% of its M&Ms are red in color. Now, think about colors of M&Ms. There's a whole bunch of them, aren't there? There's red, there's yellow, there's orange, there's green, there's blue, there's brown, there's probably one you're thinking of right now that I just missed. And so you say, this isn't a binomial. You got like a bunch of different colors. Yeah, well, you know what we're going to have? We're going to have reds, and we're going to have, and I can hear you say it in your head, it's not reds. Yeah, we're going to check to see if 40% of the M&Ms are red. We're going to randomly select 20 M&Ms, and we're going to work with a binomial where n is 20 and p is 0.4. Because we're going to say success is a red M&M. N is 20 M&Ms, p is 0.4. All right, so let's take a look at this. Find the probability exactly 4, very similar to what we've done before, right? So there are your dots. Hopefully you're saying, oh, we know how to do this. We're going to look up the value at 4. When we look up the value at 4, we're going to recognize that it isn't really the value at 4. Its probability x is less than or equal to 4. And then we're going to look up the value at 3 and get rid of it so that all we're left with is the value at 4. You can see that's exactly what I'm going to do. If only I had a table. Hey, there it is. Look up the value at 4. There's your 0.051. There's your 0.016. And so you can see every time we do an equal problem, it's a very similar problem. You look up that value in the table. You look up the right-hand value in the box. And you're saying, well, there's only one value in the box, Mark. I know. That would make it the right-hand value. And then you subtract the value just outside on the left. It's a really good way to do binomials. Look up the value on the right-hand side of the box and then just outside on the left. It's a great way of doing these. All right, the problem I really wanted to get to was this one. Find the probability more than 4, but fewer than 11 of the M&Ms are red. Now, I'm promising you this. There's going to be some of you that say, you know what, I don't need the dots to do this. And it's really easy for me to do this because I got, obviously copy and paste, I can do it. It doesn't take long. It takes me like 15 seconds to draw some dots. Which dots do I need? I need 0. I need n, which in this case is 20. I'm going to need the value at 4. Because I mentioned 4 here, and I'm going to put 1 on either side of it, and I need a value at 11. And I'm going to put 1 on either side of it. So I need a whole bunch of dots, right? That's the expression for the words here. More than 4, okay, that's more than 4. Notice there's not an equal sign there. Fewer than 11, not an equal sign there either. And so there are my dots. Which dots do I want to include? Well, more than 4, I need to get the line here. That's the important piece. I want 5 or more. Well, not completely more because I want less than 11. So I want here. I want between 5 and 10. Those two words, more, in another version of the exam becomes at least. What happens? This line slides over here. Fewer, no more than. That's what it'll change to, and it slides over here. You got to get these lines right. The easiest way for most of you to get the lines right is to draw a quick little picture. If it takes you 10 seconds but gives you like a 90% better chance of getting the problem right, take those 10 seconds. If you can't see it when you draw the dots and you're just going to guess anyway, don't draw the dots. Most of you guys will benefit from it. Because once you get the picture drawn, go to the right-hand side. We're going to look up the value at 10, but it's going to tell us the value at less than or equal to 10, and then get rid of the 1 on the outside. 10 minus 4. Piece of cake. Here's 10. Yeah, I'm looking at the right. I'm making sure I was going down the right column. 0.4. And what did I say? The value of 4. There you go. Let's subtract those two numbers. You get 0.821. Welcome, my friends, to the wonderful world of the binomial table. Your life's gotten more difficult because the table makes the probabilities a lot easier. I can ask you more complicated problems now. But in the bigger picture, I mean, in the short term, you're looking, oh, no, I got to figure out how to do this for the exam. And yeah, you do. But in the bigger picture, you can solve so much more complicated questions. These binomial probabilities that you're solving just blow away anything we can do before the binomial table. Or, in my case, the software. You can solve some pretty cool stuff here. All because the probabilities, the math part, the stuff that really gets you bogged down. Try doing these problems with the formula, and you're going to spend, an hour. You're going to run through the formula 5, 6, 7 times, and you're going to just be knocking your head against the wall because you're going to make a mistake somewhere. Use the table. Learn to use the table. Any binomial probability I ask you for, I'll give you a table to solve it with. That's my promise to you. So figure out how these things work. All right, so that's the binomial table. That's a good place to stop this video because the next step is to move on to some other distributions. So the next time I pick up, I'll be talking about some other distributions. Get working some of these problems. If you have questions, make sure you get them answered. So long.